Oh, hello, and welcome. Today we're going to pull an experiment with a bike at the top of a hill at rest. And what we're going to do is we're going to see some conversions from potential energy to kinetic energy. Are you ready?
So to solve this problem, we begin by drawing a picture. So we know that Matt and the bike weigh a total of about 86 kilograms. And to find the height, we used an altimeter app, which we got the height at the top of the slope and at the bottom of the slope. And then we subtracted those to get the height, which is about 4 meters. Then we went off to use the energy lens because we know that potential energy is equal to mgh, and we know the mass, gravity, and the height. So we found that it's about 3,000 joules, and with this we went off to find the velocity. We used this by saying that potential energy should be equal to the kinetic energy that's final, and we got a total of about 8.876 meters per second. And that's a theoretical estimate because we didn't take into account the friction, and we're gonna look what it is gonna be if there is friction.
So as you can see in this clip of Matt, he starts off at the top of the hill and rides down without pushing off, so that the kinetic energy at the bottom is just due to the potential energy at the top. If we bring that footage into Tracker, as you can see, we calibrated everything and tracked his head movement, and that allows us to see here in this graph his change in position over time, and from there we can calculate the velocity. So if we go into this graph, we can see that his final velocity is about 6.7 meters per second, and knowing that, we can compare it to the theoretical speed and figure out how much energy was lost to things like heat.
Let's calculate that. So, we know that the real world is not frictionless, so there's going to be some energy loss to heat. So we can use the equation. The initial kinetic potential energy is equal to the final kinetic energy plus some Q, or heat lost as energy. So we know that the initial potential energy isn't going to change, so we can use the same value that we found earlier. So using the Tracker program from project 1, we found that my final velocity was about 6.7 meters per second, which is roughly 15 miles an hour. So that sounds about right. So through that, we can calculate that the amount of energy lost as heat was 1,461 joules. So given that, we know that the initial potential energy was about 3,300. We lost around 1,500, so we kept about 1,900 joules of energy as kinetic.